So, as Madison told me, I'm reappearing in this series because I was actually in the first episode. So I felt I was a little bit like being a part of Friends or whatever these series are called. So I'm the reappearing person right now, with the task and the honor to welcome Raffaella from the company Kyma. Is that right, said Raffaella?
Yeah, Kyma, it's a Greek word, and should be say Kyma, I guess. So.
Kyma, okay, yeah. So yeah, and she's going to talk about the journey that they've been on. Let's say from being a spin-off company to actually make it on the international market, and this is always very interesting to listen into. So I will give the word to you after we got the picture. I remembered. Perfect. We need to get the picture with the really nice ESS cups that I have, which is plain white. But I think if you can find your enriched coffee cup, let's try to get going. Good, Jan. You're getting a mark in the black book, the right mark, not the wrong mark.
All right.
So, say cheese or whatever you say.
Yes. 1, 2, 3. Thanks so much.
Okay, next time I need to have that cup too, because I have
we send you one.
Okay.
So Raffaella, the floor is yours.
Okay, I just a few words about myself. I'm the general manager of Kyma, and before working in Kyma, I worked in the installation of a free electron laser Fermi in Elettra, and then in 2012 I moved to Kyma as project manager, and since from 2-3 years I'm a general manager here. And so I will try to give here today a perspective of what did happen in Kyma, how Kyma started, and which were the steps we made to go through these 10, 12 years. And at the end of my presentation, I have a list of tips, or I would like somehow to provoke a conversation. I would be very happy to hear from you. So I will start immediately. Let me share my screen, and here it is, the presentation, and I will go on presentation mode. So do you see it? Is it fine?
Yep.
Okay, good. So the title is quite ambitious, but let's try to, my goal was here to talk about giving an economic value to products that sometimes, or to research that sometimes is very difficult to be economically valuated. So let's start from Kyma, how Kyma was born. So Kyma was born in 2008, but the process started a little bit earlier. Elettra Synchrotron Trieste was going to build a new free electron laser and needed 18 undulators. Elettra had the know-how, but didn't have the, let's say, industrial skill or the people, the team, big enough to build such big numbers of undulator. On the same time, it was a pity just to give out a contract, and as the know-how in Elettra was very well, let's say, known and important, so it was a pity not to use it. And they decided to use a European tender path. We have to remember that it was 2006, so probably right now the option would be much wider, but in that moment that was an option, an open tender to look for industrial partners to build the undulators for Elettra. So here the interesting thing was that we had 2 industrial partners, Euromisure and Cosilab, who give cash to the company, while Elettra, let's say, gave the know-how. As I'm writing here, it was about intangible asset, no money from the Elettra, but just drawings, communication, exchanges, exchange of information. So this is, from my point of view, a very interesting thing. And this intangible asset was evaluated being the 51% of a share of a new co. Okay, so to give you an idea of the company and partners, This was what did happen, and the decision what was made after the European tender. And so we had these three partners, Cosilab, Euromisure, and Electra, as I said, owning 51% of Kyma and giving just know-how and competences and skills about undulators. Kyma was founded, and we had also Kyma Technologia, which is a company in Slovenia. I show you some picture of that. We have a building and a laboratory over there where we really build our undulators. So in the beginning, we had this company in Italy, and consider that we are inside the synchrotron area of Trieste, and we are just 5 kilometers from the border between Italy and Slovenia. So the laboratory in Slovenia is on the other side of the border. It's 15 minutes, 10-15 minutes going from here to there. But at that point, it was very nice as an idea also to build something together between two states, two nations living on a border. So Slovenia, we had this laboratory. I'm showing you some technology we had in the laboratory to tell you something very important. The goal here was clear, was the one to build all those undulators, but we need an infrastructure, very well structured, to make these undulators available, measurable, and we could also characterize them and improvement. So very important step for a startup company is to have all the equipment needed to achieve the goal you have. Here we have the first project. Another good, important, interesting point in a startup is to have what I call a hot start. So we started with a project in our hand, which is extremely important because there are many startups that have brilliant, fantastic ideas, but at the end of the story, they do not have a project or an immediate possibility to gain money and to maintain their company. So lots of startups also have problems after 1 year because they do not consider the fact that they have to be financially and economically independent. So very important for Kyma was this hot start with the project of Fermi, with the possibility to build these 18 undulators. From that day on, or that project on, we learn how to build and manufacture undulators. And right now, as you can see, we deliver more than 50, 60 undulators everywhere, and with different kind of characteristics, with also phase shifters and also other devices. I will talk later, because that was another step forward in the growth of Kyma. So we learn during the project with Fermi, we improve our skills, and at that point we were definitely ready and also interesting for the market. Here is a picture of an undulator. This is an undulator, two undulators actually we built for Brookhaven, but we started to work for Brookhaven, India, Korea, China, or everywhere in the world, building these kind of undulators. So the first step was, let's say, to let the market know that we were capable to build undulators and to be recognized as a reliable company, because it's very important to gain and conquer the recognition from the laboratories. Laboratories have to be aware of the fact that they can count on a company that can be somehow as an extension of their laboratory, and they can count on good products, good delivery time, putting the risk outside their laboratory, but giving the risk to the company. So it was very important to work with different laboratory and gaining one project after the other, more and more, let's say, reliability in the eyes of the other laboratories. Another important point was that we want to have all the products possibly and that were, let's say, needed to build the undulators under our control. And one of the key points here in the ondulators are the permanent magnets. So we decided to extend and started to look for Chinese partner to work together on the on permanent magnets of high quality. So we made an extensive research to find a partner in China. I say China because, as probably you know, the 97% of the raw material needed for the permanent magnets, which are the rare earth, are in China. So this is why we went to China to find a supplier of magnets, but we didn't want just to have a supplier, but we want to have an agreement with this supplier in order to build and to realize together the best permanent magnet we could have. So we share the quality procedure, the characterization procedure. We sent them the same devices and instrument we have and we use in our laboratory to measure magnets. So this is another key point in building, let's say, strong partnership and collaboration along with all our, let's say, companies, because as a startup you are very small and you need to be stronger and stronger and have let's say larger shoulder to bring all the risk of such complicated project. And so this was definitely a good point. And then at that, some years ago, we saw that our, let's say, reliability and recognition worldwide was achieved on undulator. And we started to think what was our added value and our know-how at that point. And we understood that we were very strong on permanent magnets, of everything related to permanent magnets and how to select them, design them, and characterize them. And so we started to diversify our product, also building other things related to permanent magnets. For example, here we realized for this C-beta project, which is a project of Cornell University together with Brookhaven, in which they needed these permanent magnets, you see, put it in this sequence in order to have dipoles and quadrupoles on in energy recovery LINAC project they have in common. And also going on in the diversification, we also built pieces of undulator, for example, structure for DAISY. And we, let's say, supply different kind of products, always related to permanent magnets. So this was the next step, to go from undulators to permanent magnet devices in general. The next step was to go ahead in wider our products. And so we started to work on in-vacuum ondulators. To do that, I mean, we have at that point the know-how about magnets, about mechanical stuff, about control system, but we didn't have the know-how about the in-vacuum part. And so in order to, let's say, work on that, we started a collaboration with another big company, which is Research Instrument, a German company. They had the know-how in IVU, in vacuum parts. And so we started as consortium to build the first ondulators. And in our company, in order to answer to the request we received, we started to upgrade our laboratory and bring it to a cleanest area in order to allow us also to build and to put together the magnets here, as you can see, of the in-vacuum structure. And this, for example, ondulator was, let's say, put together in Cezana here in Slovenia. And then the structure was sent to Germany, to Research Instrument, and they put the in-vacuum chamber around the magnets and made all the tests and all the final measurements. So it worked very well. So we got into another market of another product. And of course, to do this, we also needed to upgrade and to our magnets, so to be capable to use them for in-vacuum production. So this is, let's say, I tried to give here some hints here and there of what we did in these years. And so as promised, I'm closing this short presentation, giving some tips that could be somehow the starting point for our next discussion of the next 15, 20 minutes. So, as I said in the beginning, very good, very important was this hot start we had. So we received the know-how, and we had in our hand the possibility to have a contract. We were founded to have that contract for Electra. Then we had to carefully plan and implement all the structures. So since from the beginning, as I said, we had that laboratory with a very precise and state-of-the-art of equipment. We had to have people capable to use it. And so very important was the definition also of skill competences necessary for the business, the process, the method. So to have very, very clear idea. And when I talk about planning, it's very important to remember the financial and economic aspect. The startuppers sometimes are so in love with their idea that they don't remember that there is also an economic aspect to take care in order to survive on the long term. Then, as I am writing, develop a whole product through alliances and partnerships. So the example of permanent magnets for us, or research instrument, or other example I didn't have a time to show you. Create a market. You have to go around, and first of all, you have to be reliable, and people should trust you, and they go around. And a point here I would like to stress is about communication. We have to be capable to improve communication more and more between individuals inside the two different companies, for example, or a company and lab. They have to trust each other. You have to find a way to talk with larger partners. So, for example, if you are small, going from bottom up, focusing on relation with district or local offices. And last but not least, you have to remember that, especially in the beginning, you have to manage your own company and stimulate communication and interaction as much as possible inside your company. And this is what this was another key point for Kyma, because the transfer of the technology transfer is going through each time people from one person to another person. So you have to allow these doors to be open, just to allow people to communicate and have an effective technology transfer. So I would stop here, and if you want, I can stop sharing, or I can leave these tips. I don't know, perhaps I can stop sharing and then go back to these tips later. And so, as I said, I put here this list of tips because I'm sure that there are lots of questions and thoughts you have in your mind. And so I'm curious to know about them and to understand, first of all, if you understood or if I gave all the information needed. And secondly, if there is something we can talk together about.
Thank you very much, Raffaella. I think there's a lot of things that we can talk about. This is really impressive. And I think seen from the commercial side, it's almost like you've thrown the stone in the water and you've followed as the waves sort of moved on from the undulators into the different magnet products. It's really impressive. So I want to open the floor, and I can see Nikolai has already raised his hand. Nikolai.
Thank you, and hello, Raffaella. Good to hear your presentation.
Nice to see you.
So, Raffaella, I'm going to go back to the sort of initial order you made with Electra, and you emphasize how important that was. And I'm sort of curious, for a new company that wants to start out, how do they get that order? Because at the same time, as we discussed in this forum many times, there's also public procurement rules and everything. So it can be hard. What do you do first? Do you establish the company first, or do you negotiate the order and then you establish a company? So how did you do that?
Okay, you have to consider that this was a long time ago. I mean, I think it was really the first tentative to work together, and Elettra found this system, this way to go to an open tender. So they needed to have those undulator, and they went on a European tender looking for partners saying, listen, I'm going to bring my know-how, I'm going to bring this contract, and we need a company to build this stuff. So it was a very peculiar beginning. I'm not sure this would be feasible right now, because rules probably are changed, or I don't know if this is still applicable. But I think also that there are, let's say, different kind of approach that can be used, and will be more and more needed, in the sense that in 2006, 7, 8, my feeling is that laboratories were ready to do the devices by themselves. So there was a sort of capability, or let's say, laboratory needed to have some devices and didn't know how to build it, or there were few really possibility, and were also ready to do it by itself. So at that time, the laboratory was somehow a competitor of the companies, and it was not always very easy to work together. I think that right now, after 15 years, things change dramatically, in the sense that we have new technology. For example, we have this new low emittance ring you have in Lund, Max 4. So what does it mean? That you need more advanced technology, huge quantities, and laboratories and industry has to be able to find a way to work together. And if I mean, we were towards this technology path, towards more higher technology, COVID situation also make this more urgent to work together, to be capable to put teams together. So I'm not sure that this kind of model would be applicable right now, but for sure there are going to be lots of devices, there are lots of prototypes that laboratories going to need in the future. And so we have to find a way, let's say, to work on prototypes before going, let's say, on the product. In the case of Kyma, undulators were already a technology quite well known by Elettra. So, of course, you had to do a step forward towards the elliptically polarizing undulator, but it was somehow reasonable to do it in that way. I think that right now there are lots of new technologies that really needs to find new way of collaboration. There is a new way of procurement. I discussed also in the past with Antonio Bonucci. I saw that he also had a presentation here, and the innovation procurement, I think the name of this, I think could be a solution, for example. And so the big difficulty is right now a company or a startup has in the beginning is the engagement with the laboratory. So I think that we should focus on working together, on prototyping together. The company needs to be rewarded for that, because cannot work for free, unfortunately, for you and me, but this is our goal. And so finding new way of collaboration could somehow be a solution for a startup company. Of course, another point we need to know is what will be needed in the future. So first, what you are doing, big science business forum, for example, or this kind of meeting in which the big laboratories meet and said, listen, in the next year, we're going to need this, this, this. Who is interested? We can make this kind of procurement. We can work together in this way. I think this is the path to follow and to go ahead with. And so here we have, my feeling is that we have in embryo something very, an idea to work together and to somehow transform a know-how that is in the lab into a product. because you need the skill of an industry to have an industrialization. So this was a first attempt. It worked. I don't know if this is applicable after 15 years. I would rather think about procurement stages based on innovation.
But I think that there's probably steps that you can replicate, and there's lessons to be learned, and then you might actually, go forward with the process. And as you probably already know, like ESS is 60% of the construction here is Inkind. So that's another method of fueling industry and fueling people like yourself. So you actually get maybe national money in Italy or elsewhere, and then that will be invested or in terms of the products and the competences you're good at. And then when you have delivered, you still have the competence and the competitive advantage, let's say. So I think that you're right, there are different methods, but what you've done is very impressive.
In your case, I think it's interesting why a company should have an Inkind. Should have an Inkind because could be a way of learning and a way of working together with lab, and also it would be interesting to understand the potential market. So I know that having an Inkind, I'm gonna make a certain kind of production that allow me to have in the future a product that will be, let's say, sexy for the next market or interesting for the next market. So this is interesting in an Inkind when you have the competences, the skills, and putting together something, you can have a new product for an Inkind. And this is a good option. I think that also the solution of Kyma is interesting in the sense that it was a way to bring the know-how into a company. The interesting thing was that the laboratory didn't give money, just the private company gave cash. So, but at that point, you have to be very careful because my effort and the constant effort here in Kyma was to separate very well the interaction with Elettra, in the sense that we limited the interaction to that moment in which we received the drawings, and there were some meeting between experts in Elettra and the people in Kyma to build up this know-how. And as I said, key point is people talking together. So people from Kyma talking with the people from Elettra, knowing this. After that, formally, Elettra owns 51% of Kyma. But for example, I am in an office in Elettra, but is rented. So I have a contract with Elettra as much as anybody else should have here. And I pay the money for renting the office, the photocopies or whatever I'm using. Or, I mean, if there is any kind of project to go ahead, Elettra will not, cannot interfere in any way. So it's very important at that point to keep this border very clear, because otherwise it's very easy to misunderstand the role of one part on the other. So this is why I think that this is a very good approach. It has to be studied very well from the legal point of view. And the know-how was already somehow in Elettra. Inkind, the know-how is spread around. You put together your know-how and you're capable to deliver. Third thing I see that will be, let's say, this is why I think we should think also to other models. I'm thinking about time. We need to deliver very fast things and very innovative things. The obsolescence of the time of new equipment is becoming shorter and shorter. So I would focus on procedures that are faster, and I would like also to see more and more about circular economy. So I'm thinking about projects in which we already know, since from the design phase or prototype phase, that this is gonna last, I don't know, this device can last let's say 10, 15, 20 years, whatever. But after about 20 years, I know that I can use permanent magnets. I'm talking about my product. Reuse permanent magnets or use this, and somehow starting to think in that way. So giving, riding this way of this, let's say, sustainability or this kind of approach that is very important, here right now, and also to be very timely. So to have procedure that are very fast. As you see, the European tender started for Kyma at the end of 2006, and the company started 1 year later, and in 2-3 years were capable to deliver ondulators. Sometimes we do not have, or right now I don't think we have always so much time.
Yeah. I'm sorry, Raffaella, but we're running a little bit out of time, and I really want Jan to ask his question, and that would be the final question and answer, and then that's it.
I will try to be shorter. Yeah.
Okay, I hope it's a good one. So I'm curious about the beginning, because I've been in a similar situation where you say, okay, Electra had provided basically the drawings, but if you started from scratch, where do you get the people that actually are able to absorb the knowledge from Electra? Because if you start a company, you need people that are actually capable, and you say you don't get people from Electra, so where did you get the people from that actually were able?
Okay, we found Slovenia in Italy has very good engineering and physics school. I have to be honest, we found very good people, and sometimes I mean, having the base science in your hand and not knowing much about the know-how, it could be also a good point, because you can think in a brand new way. So it was enough to have good physicists, very enthusiastic, flexible people, and they catch very well. They really learn very fast the key points, because at the end of the story, when you have a device, there are some points in which you have to be very careful. You have to take care, I don't know, of some measurement or something that you know was going to definitely impact the final result. So once you have the know-how, is sometimes saying, listen, remember that at that point you have to be sure that you can repeat that measurement, or you have to be sure that you will be sharp enough and precise enough in this point. When you have this kind of indication, you know that that is the key point that's going to impact the final device. You focus, you have good engineers, and you develop very well. So it's not always a bad thing to have good skilled engineers and physicists. And another fantastic point, we have to remember that in the history of physicists and engineering, we have the most brilliant idea coming for very young people, talented people, but they were less than 30 years. So you have very brilliant people catching absorbing the point of attention, and on base of that they were capable to go ahead. Of course, it was always an interaction. It was not just one meeting between Electra people and but I mean, it worked very well.
Good.
Thank you very much, Raffaella. And time is up, so I'm sorry to be a little bit hard, but that is the concept of having the coffee. So coffee cups are more or less empty by now, and I just want to thank you very, very much, Raffaella. We could probably talk the rest of the day, and I hope we get a chance to talk more at some point and in some other forum. So thank you very, very much.
Thank you. Anyhow, you have my email at the end of the presentation, so if somebody wants to contact me, I will reply as soon as possible. Okay. Definitely,
and also this episode will be on video, so if we need to digest a little bit more what you're talking about, we can see the video clip again in a couple of days or weeks. So that's very good. So thank you very much for that.
Thank you, and have a nice day and nice coffee to everybody.
Thank you very much.
Bye.
Thank you.
Bye.
Bye.
Thank you for a nice talk.
Bye.
Bye.
And then I just wanted, before we sort of end this, I just wanted to say that the next episode is on Thursday, and that's a special one because it's the day of the coffee. So we've decided to make it a little bit more slack around the coffee machine and really base it on a dialogue and maybe an evaluation how this is going with these episodes and what you would like to hear and what themes you thought were good and not so good. So this is actually a Friday bar on coffee on the Thursday. Could it be more wrong or right? I don't know, but at least a chance that we can talk together, because this is very focused and I think it's been very good, but we think it's time maybe just to have a time out and talk a bit and celebrate the day of the coffee. So I hope to see you on Thursday, and so does the rest of the Enrich team. So thank you very much. And Madison, I have to ask if I forgot something, because
Nope.
I'm just thrown into this.
You're all good. All good. Thanks so much, Jimmy.
Thank you. And I don't know if there's any final comments from anybody. I think this was very, very, very interesting, but very condensed. Excellent.
Right.
Okay. Wish you all a good rest of the day, and see you hopefully next week.
Thank you.
Take care.
Great.
Bye.
Bye.